Hello, we are going to talk about GD&T today. So, what is GD&T? So, GD&T stands for Geometric Dimensioning, Focus, and Tolerancing. So, it's a system, GD&T, Geometric Dimensioning, Tolerancing, is a system used to communicate material conditions for manufacturing and fabrications, speeds up reading the drawings. This is really common in the machining world. It's less so in the welding world, which is becoming more common. And I really like GD&T. So with GD&T, we are able to express on a drawing how flat something has to be, how straight it has to be, how square or perpendicular it has to be, how round a hole has to be, how concentric a set of holes has to be, how accurately a part has to be installed, or how accurate a set of hole space needs to be. So this is a great resource for people building stuff, because if we apply GD&T correctly, it will tell us everything we need to know to make sure the part meets the requirements of the application and is functional. So it's a really good system. So how does it work? Well, first thing there are characteristics, and now the characteristics are kind of what we want the part to be. And some of those characteristics are, they got a parallelogram looking thing, and that means flatness. There's a straight line, which is straightness. There's a lot of them. There's this guy, which is perpendicularity. This guy, which is parallelism. So these are what they call geometric characteristic symbols. There's bunches of them. There's in the machining world, there's even more, but these are the common ones we're going to run into. So how they work is we apply this to what we call a feature control frame. And a feature control frame is just a set of boxes, and like this. In this first frame, the characteristic always goes. So let's say we want straightness. So I put the straight symbol in there, and let's say I want it straight within 30 thou. So O, 3O. What that means is this part has to be straight within 30 thousandths of an inch. I could do parallelogram, flat, and then 0.062 inches. What that means is that has to, whatever I'm building, has to be flat within a 16th of an inch. So this is really easy. When I build an assembly, if I've got this information, I can check myself along the way and am I, how flat am I? I put a straight edge on it. Well, I'm getting close to a 16th of a gap at the end. I'm almost at my tolerance. It makes it really easy. So the other thing we can do is add another part to this and add a datum feature to it, which would be a letter. So let's say letter B. And what that means is I'm associating this requirement for flatness to another feature on the drawing. So let's do straightness, because that's a little easier to talk about. So let's say I'm building some big box frame structure. Basically, I build a girder. I can have this, and I can relate that flatness spec to a piece of this thing. So what that means is I take this guy, and I can put the line anywhere. This is going to be a bad drawing. There, take that guy, B, big dark arrow. What that means is this is telling me that plane right there has to be straight within 0.62 of an inch to datum B, which is this. So, and how this works, it's really easy. There's no confusion. It's, yeah, I've got to be a 16th straight within that, you know, my bottom member has to be straight to my top member within a 16th of an inch. So I really like GD&T. The other thing we can talk about with GD&T is what we call Lmc and Mmc. And that is Lmc, least material condition, and MMC is maximum material condition. So this is giving me a low and high size limit on whatever part I'm building. It works just like, it is a true tolerance, but it works very similar to be, you know, if I had something that was plus or minus 0.005, I was plus or minus 0.005 of an inch. Instead of doing it that way, I can just express it through LMC and MMC. So if I've got my widget, do this number, I can do LMC is 1.000, MMC, actually, I'll do this a true plus minus. LMC is 0. Oh, I'm terrible. 995. Jeez, Mike. MMC is 1.005, and that's giving my plus or minus. That's saying I can be 0.005 over an inch, or I can be 0.005 under an inch. There we go. So what this is saying is LMC is 99.995, MMC is 1.005. And if this is supposed to be typically, I'm expressing the same thing in a different way. What I like about this is all I got to do is pull my calipers from my micrometer out, and I can say, well, it's 996. I'm in this range. I'm okay. I don't have to do math. And this is easy math. Some of the math isn't as easy. This is a little clearer to me. So wrap up GD&T. I really wasn't exposed to this until fairly late in my career, and I've gotten to the point where I really like it. It's my preferred method of tolerancing. We built a contract that was very tough to build, and it was the first place I'd seen GD&T, but it wasn't easy to build, but it explained it very easily. I knew exactly what the expectation was with GD&T, and that's why I liked it. So if you have any questions about this, come and find me in the lab, come find me online, and I will talk to you later. About this, come and find me in the lab, come find me online, and I will talk to you later.